Hello and welcome back to A Boring Revolution, your number one news source for the Boring Company, obviously, and Elon Musk. We cover everything on this channel. Thank you and welcome back. Coming to you today with an episode on ventilation shafts, escape shafts, lift shafts, just a brief kind of overlook of what they're potentially going to build on the Washington to Baltimore route. I can just see a few questions coming through, so I thought, you know what, why not? Let's start with a few questions. So, I noticed this before I started broadcasting. So that video, in terms of the actual race between the two Tesla cars, one going through the Hawthorne test tunnel and one going on the surface, it appears as though they have tarmacked the interior of that tunnel, like the base of that tunnel, unless it's painted concrete. Although the video is so small, I can't really see, and I can't even make out if they have shelves or guide wheels. It's too difficult for me to see, so I can't really speculate as to whether that is a design change or maybe they've just done it for test purposes. I think it's too extreme of a design change. I think they will stick with the concrete shelves and the guide wheels. What else have we got? Tarmac is asphalt. I think. Wait, sorry. Let's add it on here. Tarmac is asphalt. I think that is just paint. Could be a pigment that they've added to the concrete itself. Maybe. Probably unlikely though. I don't know if it's reading the lines or someone's driving it. I cannot honestly tell you. But anyway, let's get on with our presentation. We're going a bit off what we should be covering today. So, okay. Let's get started. Ventilation shafts and cross tunnels. So someone on Patreon asked me to cover this because they don't necessarily have an understanding of it and essentially want to understand what's different about ventilation shafts in the Boring Company tunnels and what is essentially different between maybe your typical rail tunnel or even a car tunnel, potentially. In the grand scheme of things, there's not really that much difference, but I will go over what I think will be different in the coming presentation. So I was asked to cover ventilation shafts. The actual vent shafts for the Boring Company, I predict, and based on what I've read, will be combined with escape routes. So we will actually have inside the same shaft, it will be segmented off, and there will be a staircase, there will be lifts or escalators, elevators, sorry. They will have the actual vent shaft itself, and you may have a utility shaft in there as well. Getting some questions coming in today, guys. Excellent. This is a boring channel. You need to evolve, man. I'm trying my best. Vent shaft will double up as fire escapes. All shafts will be subdivided for its various uses. A lift shaft is integral to safety. We can't just assume that everyone is able-bodied. Unfortunately, there may be people using wheelchairs in the pods. Thus, we need to accommodate them in terms of in any kind of escape scenario. So, why do we need ventilation shafts? What is the point? Why don't we just, build a tunnel and forget about it? Well, ventilation shafts double up as escape routes. So they've got a stairwell in the actual shaft. It needs to be a means of escape in the event of a fire, crash or explosion underground. You have to think about the worst case scenario. Someone blows themselves up and you've got pods following each other in close proximity. It could potentially result in many vehicles exploding, blocking the tunnel. You've got to have various means to get out. Vent shafts are required to dilute and displace indoor pollutants, and replenish oxygen. Allow emergency service to access all parts of the loop network quickly. One thing I mentioned is, or I'm going to mention in this presentation, is a utility shaft. In that utility shaft, there will probably be some kind of dry riser. You're probably wondering, what is a dry riser? It's basically a pipe that the fire services will use. They will fill it full of water, and then they will connect the hose pipes to it. So when they are deep underground, they've got a high pressure supply of water coming down from the fire engine. Although in this case, they might use some kind of foam additive to the water, so it gets a bit more complicated than that. Allow maintenance teams easy access to the loop system. Obviously, people need to go down there, maybe to repair things, maybe to inspect things periodically. So you've got to give access in those ventilation shafts. These two images here in the center were pulled from the Washington, D.C. to Baltimore environmental assessment. As you can see, the actual shaft runs almost at a 45 degree to the actual main arterial shaft, or arterial tunnel, sorry. At the surface, it just kind of looks like a very basic shed. I presume it will be surrounded by some kind of opaque barrier rather than this architectural glass. The Washington D.C. to Baltimore has stipulated the need for up to 70 shafts and a minimum of 20. It will be nowhere near 20. The regulators will stipulate somewhere in the region of 60 to 70 shafts, which double up as ventilation shafts and also escape routes. This is something I basically I drew this at work. I think that is the basic kind of layout that I would do it. I would not go for a circular shaft. I would go for a rectangular one because you can fit a lot more in there. With a circular shaft, you're kind of wasting a lot of space in there. So for the Washington DC one, they had one shaft per 0.5 miles of tunnel. So 35.3 miles divided by 70 is 0.5. And that's covering both the northbound and the southbound tunnel. The shaft diameter would range from 12 to 24 foot. That is for the escape shafts. But the one I've drawn here is probably closer to 24 foot wide and maybe 30, well, easily 30, maybe even 40 foot long. Example layout of a shaft. We've got two elevator shafts, A and B. We've got our stairwell. We also have landings on the stairwell, which is basically a means of allowing people who are going up the stairs, maybe they're elderly people, maybe they need somewhere where they can rest for a minute or so before they begin climbing up the rest of the stairs, because remember, some of these shafts are going to be fairly deep, so we're going to have a lot of stairs. We have our vent shaft, which is at the rear of this particular diagram here. And our utility shaft, again, they'll need obviously power for lighting. They may need water access. They may need telephone cables. May need Wi-Fi cables. So you have to provide an area where you can run that through the shaft that is going to be protected from potential fire ingress. Just note that the vent shaft is mechanically ventilated 24/7. It will be running at around 30% capacity for 99.99% of the time. In the event of a fire or an explosion, it will quickly ramp up to close to 100% to vent any smoke or any kind of poisonous chemicals. Maybe it's a chemical weapons attack. You just don't know. You have to be able to vent that tunnel as quickly as possible, very, very quickly. And you obviously require quite powerful equipment to do that, because you're going to have to do it like that. You're going to have to turn it on and get it cracking and get that ventilation in there, pumping out those toxic fumes. The potential means of building this ventilation shaft are H-piles and lagging, which they've used in the past at the Hawthorne Test Tunnel, and secant piles. Now, I've used secant piles. We call them CFA, or continuous flight auger piles, which is basically concrete piles that you drill into the ground and then you cast it in the ground. and insert rebar. That can be done in whatever shape you want, so it's a fairly simple technique, although I have never seen it used for a shaft that is more than 80-90 foot deep, so potentially we might have to use alternate methods for this. Just have a look at the spur and the shaft layout. The actual ventilation shaft there is that shape, that rectangle there. It's in the boring company's interest to keep it as close to the arterial tunnel as possible. That's going to minimize costs. And I would run it at a 30-degree angle. That way, if they do turn that into an elevator station or loop station at a later date, then the vehicles can come in and out of that point at a good speed. You don't have to do a right turn at 90 degrees. The spur will be run at 30 degrees, 14-foot diameter spur tunnel. Shaft is 60 to 100 foot from arterial tunnel. I mean, they did mention potentially in the Washington, D.C. Environmental assessment that it could be up to 0.25 miles. But I mean, why would you spend all that money to build a tunnel that long to a ventilation shaft? That is, it's a long distance. That's an extra cost that you have to incur. They'd probably use the sequential excavation method, because if you use pipe jacking, you've obviously got to put the machine in and you've got to take the machine out. In this particular instance, I don't think that would work. The sequential excavation method using shotcrete is well known and it can be done fairly easily. Let's see if we've got any questions. No questions so far, but if you've got any more questions, please send them through and then we can answer them at the end. Cross tunnels. A cross tunnel is a structure that connects two tunnels running parallel to one another. So obviously, for all the projects that the boring company are going to do, including the Las Vegas project and the Baltimore project, they're going to have tunnels running northbound and southbound. You need to make connections between those tunnels in the event of an accident or an incident, or in case you need maintenance teams going in there. So you'll run a very short tunnel in between those arterial tunnels. It'll only be around 14 foot long because the boring company will run the tunnels very close to each other. Could be as little as 8 foot 6 inch wide by 10 foot tall. There's tunnels in the channel tunnel that are very narrow and they're just there for escape means, and they're never used really, but they need to be there just in case of worst case scenarios. They will only be for pedestrians with that kind of width. Would require a fire door. Obviously you need to prevent fires from spreading in between tunnels. If there's a vehicle pile up, say, and also you've got smoke coming through, you don't want smoke going from one tunnel into another tunnel. Potentially that could cause an accident on the other side, so you'd have a fire door in between. Cross tunnels are essential. I think they should be built every 0.2 to 0.4 miles. Obviously it depends on what they're building. For the Washington, D.C. to Baltimore one, I would recommend that kind of distance. For the LA, Las Vegas tunnel, Las Vegas, Nevada, I would recommend that maybe they only have maybe 2 or 3. They're not necessarily that, maybe even less than that. They're not necessarily required for that particular project because you've got 3 stations. Vehicle cross tunnels, this is something that I only thought of today. Potentially you might have an area where vehicles can cross over between tunnels. It's never been mentioned on any documents that I've read about in regards to the boring company, but it makes sense that if you have an incident where a vehicle becomes disabled, maybe vehicles need to escape using the other tunnel, there could be an area where they could cross over and then exit via the nearest spur. Alright, so what's my take on what we've covered today? Vent shafts need to be 100 foot to 180 foot deep to incorporate additional lower level tunnels. If the boring company wants to have 4, 5, 6 levels of tunnels, they're going to need to start with a shaft that is 180 foot deep, and they can add the different levels rather than having to basically extend the shaft at a later date, which would cause major problems in terms of you might have to decommission that fire escape for a short period of time, which what are you then going to do? You're going to have to build another fire escape while you're decommissioning that one and extending it. So it doesn't make any sense. You're better off building a nice, 100 foot deep shaft that you can then extend at a later date, get another 3 levels out of it. Ventilation system, I think that it would be very beneficial if they did a computer simulation, like a 3D model of potential scenarios where you have multiple vehicle pile-ups in the tunnel, big fires. Where's the smoke going to go? How are you going to extract the smoke? How much smoke can you extract with 30 shafts, 40 shafts, 50 shafts? That kind of thing, and then work out what's the most optimal number of shafts, rather than just putting in 100 shafts and saying, well, that'll definitely sort it. Well, you might have 40 more shafts than you actually need. So that kind of computer simulation model will help them with efficiency and saving money, but they should still over design it so that, absolute worst case scenarios, you have power failures at the surface and you have a multiple vehicle pile up that you can deal with it. Ductwork is necessary from the spur entrance to the vent shaft. So what I'm saying there is that the ventilation shaft comes down from the surface, and then you have ductwork that is linking that vent shaft from essentially underneath the stairwell all the way down the spur into the actual arterial tunnel itself, rather than sucking smoke into the stairwell, which is an absolute no-no and could potentially cause the deaths of hundreds of people. You need the ductwork to go from the actual vent shaft down underneath the stairwell, down the spur, and there you go. That'll fix your problem. So escape routes need to be both large and numerous, regular intervals. There's no point, I don't think, for this particular scheme, or for any scheme that the boring company does that's of a big size, I don't think there's any point just having a vent shaft. I think the vent shaft should be part of a shaft that has got a stairwell in it and maybe a lift. I think absolute minimum is a stairwell. They've got to have that and a vent shaft. Thank you for watching, guys. Appreciate this was a bit of a boring topic today, but someone's asked me to cover it, so I wanted to get that sorted so that we all know, what I'm talking about when we do talk about other schemes in terms of how important ventilation shafts are, how important cross tunnels are, and obviously how important it is to have regular stairwells so that people can escape in the event of a fire or an explosion. Please like and subscribe. Join me on Discord, Twitter, and Instagram. Really appreciate it. Those links are down in the section below the YouTube video. I'd appreciate some feedback on this video, good or bad. Thanks to my Patreons, Ashley Hill, Mike McLean, David McKay, and Christopher Kinsey. Thank you for watching, everyone. What we'll do is we'll go to our questions. If I can work out how to do it. In fact, you know what I'm going to do? Get rid of that. So, has anyone got any questions that they'd like to ask? I've seen a few things coming through. Diglett evolved into Dugtrio. I'm not sure what that means, but just while we're here, before I go, I found this website a long time ago, and in here there's a lot of detail. I also found this document, which is the project contract for the Las Vegas loop. So I'm pulling a lot of my information from this document now, which is phenomenally detailed. There's a lot of crap in there, but there's nuggets of gold. Now, if you remember, I was talking about that Guardian article where they had actual figures for how much it was going to cost if the Boeing company didn't finish on time, or didn't have sufficient capacity in the system, or was unable to open the system on time. I think they pulled it from here because they've given the percentage of the actual contract. So my theory was correct, that someone somewhere has got access to this contract and either gave it to the Guardian, or potentially made a mental note of these numbers and then handed on the information. But there's definitely someone on the inside, definitely. In fact, you can't even see what I'm saying here, can you? Oh dear. There we are. Sorry, I was on the wrong screen. Let's go through some questions. So, tunnels need to be straight. Do you favour legislation to define homesteading law under surface properties? So, I presume what you mean by that is what you, as a homeowner, what you own underneath your property, how many feet or meters of land that you own, that basically you decide what goes under or through your property, essentially. I would favour any legislation that makes it easier for people to build tunnels under property, under the condition that were something to go badly wrong, the levels of compensation would be extremely high. I think allowing people the first 80 foot underneath their property is reasonable, or maybe 100 foot. I think giving people everything underneath their property to the centre of the earth is bonkers, and that kind of legal that's how it is under the law. Essentially, is you own everything under your home to the centre of the earth in some countries, and I believe the US is one of them, and it just doesn't really work very well. It stops projects and it helps the NIMBYs. So yeah, I do favour that. What about underwater? So, in Norway, they're building a lot of tunnels that they basically mounted underwater, and they don't float. There's something on the surface that floats, and then they're suspended. It's like it's a bit like a cable stay bridge, except that the tunnels are mounted or set underwater, and then they hung almost like curtains. I think that approach is very expensive indeed. So I don't particularly like that kind of approach. I'd rather they go very, very deep underground rather than going through the water. Let's see what other questions we've got coming in. Good question, that. What about a standard third tunnel for an escape route instead of a staircase? Yeah, that's what they do for the channel tunnel. I think that works quite well. I seen a video where someone drives a Jaguar I-Pace down the central tunnel in the channel tunnel, and it's around the same size as the boring tunnels, and it does, from a safety point of view, Chris, I think that approach works very well. It's just the cost of it. But yeah, I mean, if it can be justified, the cost, then I'd say that is probably the safest solution. Because what you've got as well, if you've got cross channels running between your tunnels, and then someone, if there's a crash in the tunnel, then you've got people exiting pods and then going across that cross tunnel into the other tunnel where traffic is heading the other way. Potentially that's, another accident waiting to happen. So having that third tunnel in the middle would negate that, and it would also be a lot safer because you could pressurize that, and that would prevent smoke from coming in from any accident. So yeah, I agree that is a safe. I don't think that the boring company will go that route though, because it increases your costs straight away by 33% because you're having to dig another tunnel. Joe Kiff. Could shafts be located above dual tunnels so they would take refugees from both directions, possibly up the ramp initially? Yeah, I mean, that kind of goes off what I've just been saying there. Because if you're unlucky, you could end up being quite a way away from the actual escape shaft. This is why I think when the boring company says for the Washington DC project especially, which is 35 miles, saying that you only need essentially 70 escape routes is just nowhere near enough, and we've got to be really careful where we're pushing the boundaries here. Somewhere around 100 escape shafts and vent shafts would be better in my eyes, and then you could have escape routes on both sides for both tunnels, and then you're not having people crossing over between tunnels to try and get out, because that is potentially dangerous. It's interesting. I was thinking 30 foot sounded good, but a person might later want the near for their own access tunnels later. Yeah, it's difficult to say. It's difficult to say. I don't know why those laws are in effect. I'm guessing that people at some point in time, certainly in the UK, there were cases where people would actually dig very shallow coal mines in their own backyard, and I wonder if it's come from there and then maybe it was picked up in the USA. I don't know. But I think somewhere around the 60 to 80 foot mark is reasonable. Or at least have some kind of mechanism whereby you could buy the land under someone's house that at 200% above market. You know, some kind of reasonable provision where you could buy that land, and the person that owns the property couldn't stop you from buying that land, but you had to pay them 200% above market value for that parcel of land. I think that's reasonable, but the laws need to change in some countries, otherwise we're going to get stuck and projects won't progress. Bubble Elvis, hello, nice to see you again. Hello to everyone as well. Pods EVs could be programmed to give assistance in a tunnel calamity. I like that word, calamity. I am assuming here that all EVs in the same tunnel have a hive. Yes, absolutely, brilliant point. All the vehicles, they work in unison. So in the event, let's tell you what. Here's a scenario. Yeah, we've got 5 vehicles in a convoy. The middle vehicle has a suicide bomber in, and he blows himself up. Everyone dies in that vehicle. The vehicles behind it and the one slightly in front is also damaged. So what you've got now is you've got essentially 3 vehicles that are, disabled. The people are okay, but they're disabled. You've got smoke in that tunnel, and then you've got vehicles coming up behind. You need a way that those people can quickly escape. Now, it might actually be quicker if the pods start coming off behind, and then the other pods actually start reversing and then coming out. If they all work in unison, because they're not going to have a crash with each other, because they all know where each other are, it might just be a case of reducing the operating speeds to around 30 miles an hour, and then saying, right, all the pods reverse here, all the pods here, you can't access that tunnel, and then it works it out itself. It's almost like a form of artificial intelligence or machine learning. So good point that. Zacchaeus. Do you think it's possible to do a high-speed tube/tunnel going to the north of the UK from London? If so, how and when? Oh, right on my street. High-speed tube tunnel. Yeah, of course, it's definitely possible. It's just what's been holding that back from happening over the last 100 years or so is just cost. That's all it is. There's no from a construction perspective, from a civil engineer, I can tell you that's definitely possible. It's just that when you calculate it end up costing like 300-400 billion pounds. So but with the Boeing company, potentially with enough TBMs, once they get their third iteration of Godot out, which would be proof rock, and they can get the costs down, there's no physical reason that couldn't happen. It could just follow the M6 or the M1 straight up from London, and then you could have spurs going to all the major cities. There's even if the geology is not that favourable, you could just essentially go under areas which are troublesome. So yeah, good question that. Thank you for all the questions. This is excellent, guys. Really excellent. I'm quite. I didn't expect many people to come in today because it was a bit of a boring episode, but we're getting some good questions actually. So maybe it wasn't that boring. If a person can't stop you from buying, then there is no such thing as a market value. I was suggesting that since they don't use it, they don't own it. If you only need to be insured or bonded against. I think there would be a way that you could value that land under someone's house. And it's obviously valuable because they own it and you don't. And the boring company needs it to get their tunnel finished. So if your house was worth $500,000 and you work that out in terms of because it's three-dimensional, so it's not going to be meters cubed, it'll be meters. No, it wouldn't be meters squared, it'd be meters cubed. So if you could work that out for your house, if your house is worth $500,000, and the land as well, the land that it sits on, then you could say, well, that land underneath my house is worth $1.8 million. If you want to use it, then you're going to have to pay that. And that's, and there must be a fair mechanism for calculating that. But if the law was simply that it was 80 foot below your house, you own, and then everything from 80 foot to 800,000 foot is not yours, then the boring company could just simply just go underneath, which would probably be an easier solution than what I'm suggesting. I'm trying to overcomplicate things, but yeah, you know what I'm trying to drive at here. Subsidence, the land is free, though homesteading. Okay. Boring Calgary, how you doing, mate? I think we need to discuss the impact that the pod has on transportation. The pod could replace local buses with places like rails, trains, local disability buses. Good point. I've not thought about local disability buses, and we have those in the UK as well. Basically, like these small minibuses that pick up certain children from special needs schools. And they are incredibly expensive because you've got to, have all these kids in special needs, and then you've got to drop them off individually, and sometimes it takes a while to get them out of the minibus itself. But I'm all in favour of trains and buses and trams, but I think that the most cost-effective way of moving people around is now this boring company system. Once we've got Tesla autopilot at level 4 or higher. So there's no reason why we can't try this out and see how it works. Somewhere like Las Vegas is the perfect testing ground for this. So if they could build a tunnel down the strip of around 20 miles and then connect that up to the convention centre and then connect that up to the airport, imagine the usage of that. Imagine Uber. Uber in Las Vegas would probably go out of business. They'd probably have to close that franchise. And if there's local buses running up and down the strip, why would people use them? They'd be priced out of the market and then they'd go under. So it would have a huge impact. Unfortunately, some people would lose their jobs, but I think there'd be other jobs created in other places. And it may open up other areas of the strip for developments, bigger casinos, you never know. So in the grand scheme, it might actually create jobs. But yeah, a great question. That great questions. I honestly can't believe how. I hope you've been preparing these questions because they're outstanding. Sorry. Brent Quaid, what about the HEPA filters in the Model X? Could they clean the smoke and make it safer to stay in the undamaged pods? I presume, and this is based on a guess, that HEPA filter in the Model X could be used, but in the event of a fire, sorry, got a cough. In the event of a fire, I think that HEPA filter would be blocked fairly easily after about 5 minutes. So unless you could get out of the tunnel really quickly, it'd be very difficult. I'm actually losing my voice now. they suffer subsidence and declare homesteading. Yeah. So, I've got a friend of mine, and he does. He surveys properties prior to people building next to those properties, and that would include in that Thaddeus. Pole surface minimize. I've got a frog in my throat and I can't talk. Oh God, I've had a cold for the last 2 days, so I don't know if this is. Most countries have eminent domain laws that can be used for infrastructure construction. Yeah, they tend to be very slow though. As a good example of that, high-speed rail here in the UK, they're having to acquire something like 3,000, 4,000 properties along the route just to Birmingham. So that's only halfway. And, oh my goodness, it's turned into an absolute disaster. They've been offering people 1/3 of what the property's worth. They've been acquiring properties and then not paying people for several months. So clearly that system is not, essentially here in the UK, is not fit for purpose. Eminent domain, yeah, that's what it's called. Thanks, mate. Thank you very much. I appreciate things like that. Thank you for staying with the channel. Thank you for supporting me. Okay, guys, before I lose my voice, I'm going to have to cut the feed. So thank you for watching. Appreciate you staying with me. Really appreciate all the questions coming in. This is phenomenal. Please keep it up. I'll hopefully have an episode out in the next sort of 3 or 4 days. In that meantime, I'll try and work on my voice box because it's gone. Thank you. And yeah, hopefully see you soon. And remember, don't be boring. See you soon. Goodbye. Thank you.